Alright, in this video we're going to look at the examples from the lesson on tangent and normal lines. Hopefully you read through the first page of the notes on tangent and normal lines so that you know what a tangent line is. When we find tangent lines, we need two things in order to write the equation of a tangent line quickly and easily. Those two things are we need the point of tangency, and we need the slope or instantaneous rate of change of the curve at that point as well in order to write the equation of the tangent line. So, in example 1 here, we're supposed to find the equation of the line tangent to the curve y equals x squared at x equals 2. The first thing I'm going to do is find the point. I'm just going to go ahead and take that x coordinate and substitute it into the original function in order to find the y coordinate of the point. And so y is equal to 2 squared, so y is going to be equal to 4. And that is my point of tangency. And now I need the slope or instantaneous rate of change at that point. In order to find that, we're going to use our limit and find the instantaneous rate of change. So we want the limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. And now I'm going to establish what that looks like. The f of 2 plus h is the quantity 2 plus h squared for this function. And f of 2 is the quantity 2 squared. And now I'm going to go ahead and simplify that out. That gives me 4 plus 4h plus h squared minus 4 all over h, which then the 4's cancel each other out, and it becomes this. And I'm going to go ahead and factor h out of the numerator. And so this becomes the limit as h goes to 0 of the quantity 4 plus h. And by substitution, that limit is 4. And so that's the slope of the tangent line at the point of tangency 2, 4. Now all I need to do to write the equation of the tangent line is use point-slope form of an equation. So I'm going to take y minus the y coordinate of the point is equal to slope times the quantity x minus the x coordinate. And there's my equation of my tangent line to the curve y equals x squared at x equals 2. Alright, let's move on to example 2. And in example 2, we are going to be finding a normal line. A normal line is a line that is perpendicular to the tangent line at the point of tangency. And so again, we're going to need two things in order to write a normal line. We need the coordinates of the point of tangency, and then we need the slope of the line perpendicular to the curve at that point. And so what we're going to do is we're actually going to find the slope of the tangent line at that point, and then use the fact that the tangent line and normal line are perpendicular, so their slopes will be opposite reciprocals in order to find the slope of the normal line. Okay, so those are the two things that we need to find. So first I'm going to go ahead and find the point when x is negative 3. I substitute that into this function, and I get that the y coordinate is 6. And now I'm going to use my instantaneous rate of change formula to find the slope of the tangent line at that point. So I've got the limit as h approaches 0 of f of negative 3 plus h minus f of negative 3 all over h. And that is the limit as h goes to 0 of negative 3 plus h quantity squared plus negative 3 plus h minus negative 3 squared plus negative 3, all of that over h. And now I've got some algebraic work to do. This is going to be 9 minus 6h plus h squared. minus 3 plus h minus 9 plus 3 all over h. And a few things are going to cancel out for us here. This 9 and the minus 9 cancel each other out. The minus 3 and the plus 3 cancel each other out, leaving me with negative 6h plus h squared plus h all over h. I can combine the h's, gives us limit as h goes to 0, of negative 5h plus h squared all over h. And now I can factor the numerator. That's going to be the limit as h goes to 0 of h times negative 5 plus h all over h. And now the h's in the numerator and denominator are going to cancel each other out, leaving us with this limit, which I'm going to find by substitution. Now this is the slope of the tangent line. So the slope of the tangent line to the curve here is negative 5. And therefore the slope of the normal line, since it's perpendicular, is going to be the opposite reciprocal of that, which is positive 1/5. And now I can write my equation for my normal line. And my equation for my normal line is going to be y minus the y coordinate is equal to the slope times x minus the x coordinate. And there's my equation for my normal line in example 2. Alright, that's the end of this lesson on finding equations of tangent and normal lines. See you guys next time. Have a great day.